हो गया रिकॉर्डिंग? अभी टाइम है रिकॉर्डिंग So, good morning students, and rather it's good afternoon. In today's sprint, I'll cover the rotational dynamics. My coverage will not go up to the level of JEE Advanced. It will be limited up to the JEE Main and NEET. And one thing, those who have a little bit knowledge about this subject, the coverage will be in the form of questions and in the form of conceptual points. I hope the coverage will be so exhaustive that it will definitely make you solve the question in the JEE Main or the NEET this year. So look at this. First of all, you have to understand that what is pure rotation. Pure rotation is what? If axis of a body is fixed, axis of the body is fixed, and the body rotates about that axis, this is called pure rotation. What is translation? Translation. If a body goes on a straight path, body moves rectilinearly on a straight line, that is what translational motion. Then what is rolling? Rolling is if a body rotates about some axis and the axis itself translates. Body rotates about some axis and the axis itself translates. There's the rolling. And in rolling also, what is rolling without slipping? Rolling without slipping. This is what, if speed of the body, speed of the axis is v, angular velocity is omega. So v equals to omega r. If this relation is fulfilled, if there is an acceleration a, then the body will have angular acceleration also. Angular acceleration about the axis of rotation, and a will be related to what? Alpha into r. And when the body completes one rotation, its axis should translate by a distance 2 pi r. These are the conditions of pure rolling, means the rolling without slipping. Otherwise also, if these relations are not fulfilled, velocity is there, omega is there, acceleration is there, alpha is there, but these relations are not fulfilled, it will be rolling, but that will not be rolling without slipping. When it is a rolling without slipping, the body moves on the ground, then the lowest point of the body which is in contact with the ground will have zero velocity. जो body का point ground के contact में है, उसकी velocity क्या होगी? Its velocity will be zero. So this is about the pure rotation, the translation in the rolling. Then see we have, next is to understand this chapter you must understand how to calculate the torque. Torque, you should know how to calculate the torque. So see the calculation of torque is like this. In the scalar form, torque is a vector quantity. I'll separate it to the direction of the torque. The calculation of torque as a scalar quantity is like this, see. Means magnitude of torque, how to calculate the magnitude of torque, it's like this, see. Suppose this is a body. Body is free to rotate about this axis, about the vertical axis. We apply a force on the body at this point, F. F is the force. This is the line of action of the force. Then the perpendicular distance between the line of action of the force and the axis is measurement of torque tau. So magnitude of torque tau will be equal to what? R into F. This will be what? R into F. So R is not any arbitrary distance. R is the perpendicular distance of the line of action of the force from the axis. Like if there is a rod suspended from this point, if we want to calculate the torque of the weight of the rod about the point 2, so mark the line of action of the force, weight will act from the center of mass, it is mg. This distance is L by 2, so The torque will be what? Mg into this angle is theta. Perpendicular distance of the line of action of the force from the axis is what? This L by 2 sine theta. So this torque will be what? Mg L by 2 sine theta. This is the calculation of torque in the scalar form. And you have to remember that torque will always be directed along the axis of rotation. If a force tries to, rather if a torque tries to cause the rotation of the body in the clockwise sense, the torque will be directed along the axis towards the observer. If the torque tries to make the body revolve in the clockwise direction, the torque will be directed along the axis away from the observer. जैसे इस केस में this will try to make the body revolve in the anti-clockwise sense. So torque will be what? Along the axis upwards, because we are seeing it from the upper side. So observer is in the upper side, then only the rotation is clockwise, it will be clockwise. It is anti-clockwise, so it will be directed what? Upwards. In this case, the torque of mg will try to revolve the body, that is rod, about O in the clockwise sense. So there is the axis of rotation. About this axis body is rotating. So torque will be directed into the plane of the board. It will be what? Away from you, because the rotation is what? Clockwise. This is the direction of torque. Now see, when you calculate the torque in the vector form, the calculation of torque in the vector form is like this. See, it is this is the body, this is the axis of rotation. In the point from where axis of rotation of the body passes has got the position vector r1. In the point where you are applying the force F, this is position vector r2. Then torque in the vector form, torque of this force about this axis, torque of the force which is applied at the point P about the axis that passes to the point O will be tau equals to r cross F. That will be vector r2 minus vector r1 cross F. So vector F will be given in the form of I cap, j cap, k cap. R2, R1 will also be given in the form of I cap, j cap, k cap. You can calculate torque. This will be the torque in the vector form. So this is the definition of torque when you have to calculate that in the vector form. Now see, after the torque we have the parameter moment of inertia. So you must remember the moment of inertia, all the popular objects about the central axis. Then you should know how to calculate the moment of inertia. If you know the moment of inertia about one axis, then how to calculate the moment of inertia about another axis by using theorem of parallel axis and theorem of perpendicular axis. That you should know. About the theorem of parallel axis, the special point is what? Like this is a center of mass. You know the moment of inertia about an axis that passes through the center of mass is IC. There is another axis at a distance x1 from it. Mass of the body is m, and this axis is also parallel to the previous axis and is at a distance x1 from the center of mass. About this is I1. There is another axis at a distance x2 from it. About this axis, the moment of inertia is say I2. All the three axes are parallel. Then see, I1 will be equal to IC plus m x1 square. But I2 will not be equal to I1 plus m x2 square. So notice this. Means what? If you want to calculate the value of I2 and I1 is known to you, so through the I1 first calculate IC. When you get the value of IC, then I2 will be equal to what? IC plus m x1 plus x2 whole square. So in the theorem of parallel axis, it's always the IC. It's always related to an axis that passes to center of mass. If you know the moment of inertia about that axis, you can find the moment of inertia about another axis which is parallel to that, and is away from the center of mass. Then we have one parameter. So you should know how to calculate about the theorem of parallel axis. Important thing is what? Suppose I1 plus I2 is equal to I3. Then I1 and I2 are what? I1 and I2 are the moment of inertia of the body about two axes which are lying in the plane of the body, which are passing through the center of mass, and which are mutually perpendicular. Then I3 is the moment of inertia of the body about an axis that passes through the center of mass and is perpendicular to the plane of the body. So it's not key. Any two axes, I1 plus I2 equals to I3. I1 and I2 are the moment of inertia about an axis that pass through the center of mass, are lying in the plane of the body. Axes are lying in the plane of the body and are mutually perpendicular. And I3 is the moment of inertia about an axis that passes through the center of mass and is perpendicular to the axis, is perpendicular to the center, perpendicular to the plane of the body. So the theorem of parallel axis and the theorem of perpendicular axis can be applied in tandem also. Means what? You take the help of one axis, through that you get one result, then you get the moment of inertia, you apply the other theorem to get the final result. And there's one more point you have to remember is the radius of gyration. Radius of gyration. So about this point, about the radius of gyration, the concept is what? If the examiner asks you to calculate the moment of inertia about certain axis, about a certain axis, what you have to do? Calculate the moment of inertia of the body about that axis. Calculate the moment of inertia of the body about that axis. When you calculate the moment of inertia of the body about that axis, keep that I equals to mk square, where m is the mass of the body, k is the radius of gyration about that axis. That is about the k. But see, when you know the moment of inertia of all the popular objects about all the generally usable axes, those axes which are used more widely in the questions, and you also know the theorem of parallel and perpendicular axis, then after that, see, you should also know one thing, the fundamental definition of moment of inertia, because sometimes the moment of inertia, the question that comes, the moment of inertia of the body is calculated from the fundamental definition. Maybe you cannot find that what equations you already know about them, that you cannot calculate that. For example, you see, this is a rod. Now the linear mass density of the rod is rho equals to rho naught into x, where x is the distance of any point from this axis, this vertical axis O dash. Length of the rod is L. Length of the rod is what? L. Rho naught x is the linear mass density, means mass of the unit length. So the different elements of the rod at different points are what? Of different mass. Now you have to calculate the moment of inertia about this axis. So now see, even if you know the moment of inertia of a rod about an axis that passes through the center of mass, you know the moment of inertia of a rod about an axis that passes through one of them, you cannot solve this question. So this is how the definition of moment of inertia has to be used fundamentally. The fundamental definition is what? If you have a particle, the small element of the rod of length dx is a kind of particle. The particle is rotating, means particle will rotate in a circle of radius x. When the body will be rotated about this axis O dash, this particle will rotate in a circle of what? Radius x. Mass of this particle will be what? M by L into dx. Mass m into x square. So particle's mass is m. This is the mass of the particle. This is the distance from the axis mx square. This is the fundamental definition of the moment of inertia. Now see, mass m by L, mass of the unit length is what? Rho naught x. So here rho naught x dx x square, its integration from 0 to L will be the moment of inertia. So this is what I told you, ki maybe you remember the moment of inertia about this axis, that axis of this body, that body, but in that case maybe you have to use the fundamental definition of moment of inertia, nothing else will be used. So it is one of the example of that. I just give you one more example in which only the definition will be used. You cannot use the theorem of parallel axis, perpendicular axis, or any definition. Like say, there is a rod of mass m, length L. The rod is rotated about an axis passing through one end, and it is O dash, this is the axis. Now see, we have to calculate the moment of inertia of the body about this axis. What we do, we take a small element of mass length dx. So mass of the unit length is m by L. Mass of the dx element will be this, mass m, into what is the distance of this element from the axis. It is this. This angle is given by the examiner. It's theta. So this x, this will be x sine theta. So x sine theta whole square. This is the moment of inertia of this small element about this axis. Its integration from 0 to L for the x, that will be the I. So once again, we are not using the definition of, we are not using the formula for the moment of inertia of the rod, or using the definition of theorem of parallel axis or theorem of perpendicular axis. So these kind of questions are to be calculated by the basic definition of moment of inertia. Now the next important parameter is what? It is the angular momentum. Angular momentum. So about the angular momentum also, you'll see about the angular momentum. Say there is a particle of mass m, it's moving with a velocity v. There is a particle of mass m, it's moving with a velocity v. We have to calculate the angular momentum of the particle about the point P. Then it will be what? You see, first angular momentum is also vector quantity. All these parameters, alpha, torque, angular momentum, theta, angular acceleration, they're all axial parameters. They are always directed along the axis of rotation. The clockwise or anti-clockwise are their senses of rotation. They're always, these parameters are directed along the axis of rotation. If you are the observer and for you the sense of rotation is clockwise, the parameters will be directed away from you, along the axis away from you, and if the sense of rotation is anti-clockwise, then that parameter will be directed towards you. It will be directed towards you along the axis of rotation. So now see, I tell you how to calculate the angular momentum of a particle. This is of a particle. This is the first. I'm telling you only to calculate the magnitude. It will be momentum P into what? Perpendicular distance of the line of action of the momentum from that point about which you want to calculate. I want to calculate about P. So this is the line of action of the momentum. Draw a perpendicular, this is R. So this is what? MBR. This is the magnitude. This is what? It is the magnitude of R. So this is what? MB into R. It is about the particle. Whenever you want to calculate angular momentum of a particle about some point, this is a way. Second, angular momentum of a body that is rotating in a fixed axis. It is this. It's rotating in a fixed axis. You see why I'm covering the topic in this way? The reason is that there are variety of questions in the chapter, so the chapter cannot be covered by just some questions. There cannot be some important questions, though in this coverage I'll be covering those important questions, but the chapter has got variety of questions, so only through some questions, 5 or 6 questions, the chapter cannot be covered. So that is why I'm describing the chapter in this way for the sprint also. Now see, so the second is what? Axis of the body is fixed. Body is rotating about a fixed axis with an angular velocity omega, and about this fixed axis its moment of inertia is what? I. Then its angular momentum L will be equal to I omega. So you had to calculate the angular momentum of the body about this axis. About this axis its moment of inertia is I, and its angular velocity about this axis is omega. Then angular momentum about this axis L will be equal to what? It will be I omega. Then see, after this you have the third, that is in rolling motion. When a body is in rolling motion, how to calculate its angular momentum? Like suppose there is a wheel, and this wheel is in the form of it's a disc. It's in the form of a disc. This translating with the velocity v, rotating about this axis with the angular velocity omega, and you have to calculate the angular momentum of the wheel about this point, say P, about this point P. So listen this carefully. This angular momentum L will be equal to sum of the two angular momentums. One, first of all, deal that body as a particle. Mass of the body is m, say. Deal the body as a particle. So particle is translating with the velocity v in this side. So first term will be what? It will be the angular momentum of the body as a particle, angular momentum of the center of mass of the body, center of mass of the particle as a body, same angular momentum of the center of mass as a particle about the P. That will be what? MBR. R is the radius. And also see that this is of what sense? Clockwise. Then plus what? Plus angular momentum of the rotation of the body about an axis that passes through the center of mass. So about this axis, if its I is moment of inertia, omega is the angular momentum, then this will be equal to what? It will be equal to I into omega. This will be equal to what? This will be equal to I into omega. So remember that, just not कि ये formula याद हो गया, you have to remember its generalized version. What I told you, suppose I was not calculating angular momentum out this point, I was calculating angular momentum out this point. Then this will be what? Angular momentum of the center of mass as a particle about this point. So that is mv into this perpendicular distance. Plus what? Angular momentum of the rotation of the body about the center of mass. So that will be what? I about this point, omega about this point. And this is also of clockwise sense. And about as a particle, when the body goes like this, mv into r is also of clockwise sense. So both are of clockwise sense, so there is plus. Is that clear? In case the motion had been pure rolling, then only the one parameter v or the omega would have been given to you. So you can, because v equals what? Omega into r. So you can find in that terms of that parameter v or omega also. Only in terms of v or only in terms of omega also. This is about the angular momentum. Now see the same thing about the kinetic energy. If a body is rotating about a fixed axis, then about the fixed axis, its kinetic energy will be half I omega square, where I is the moment of inertia about this axis and omega is the angular velocity about this axis. This will be half I omega square. If the body is rolling with the velocity v and about the center of mass, its angular velocity is omega. There is a center of mass about this point, its angular velocity is what? Omega. Then its kinetic energy of translation will be half mv square. But remember that v is not the velocity of any arbitrary point. V is the velocity of the center of mass. V is the velocity of the center of mass. Is that clear? Suppose this is a disk of mass capital M and they stick one block of mass small m at the circumference. Then the center of mass will be somewhere in between. And in that case, the velocity of the center of mass will not be v. Velocity of the center of the disk is v. Velocity of the center of mass will be something different. So here in the formula, it is what? Half total mass of the body into vc square, velocity of the square of the velocity of the center of mass, plus what? Half I. So I is not about any arbitrary point, it's about center of mass into what? Omega square, where omega is the angular velocity. So see, for the JEE main, generally it will not be like they will disturb the center of mass by sticking some mass somewhere else. Generally it will be about the simple bodies, and if the motion is pure rolling, then Vc and omega are also related as what? Vc equals to omega into r. So this is the calculation of what? Kinetic energy. Then see, after that, like you use the equations of motion in the translational mechanics, v equals to u plus at, v equals to u plus s equals to ut plus half at square, v square equals to omega square plus r square omega square, v square equals to u square plus 2as, etc. All those equations can be used for the rotational motion also. I'm talking about not rolling, I'm talking about what? Rotational motion. So in the rotational motion we have v final equals to omega, omega final, I'm only telling you the replacement. V will be replaced with the omega final, u will be replaced with the omega initial, L will be replaced with the alpha, S will be replaced with the theta, time will remain time. So you can make all the equations for the rotation also. Here you have to keep in mind the unit also, like if theta is in degree, then in alpha also the unit of theta angle will be degree. Here also it will be degree, here it will be degree. If it is in radian, it will be in radian, and accordingly you will get all kind of questions that you did in translational mechanics, you will get about this also. So like what kind of questions are there? Suppose they give you that if fan is rotating with 1000 rpm with initial angular velocity what? 1000 rpm. Now it's given in terms of rpm, so you can calculate that in terms of rps, and after the rps you can also get that in terms of what? Radian per second. You can get that if it is necessary. If it is not necessary, you can use the unit rpm on rps also. Now what they say? It is switched off. It is switched off, and it is found that when its omega falls to half of the initial omega, it has rotated till then 1000 rotations. So till it stops completely, how many more rotations will it cover? So the question is exactly like what? Omega final square equals to omega initial square plus 2 alpha theta. So in the first equation you will make omega final, you will keep omega naught by 2, omega initial becomes omega naught minus 2 alpha. In place of theta you can write the number of rotations as it's given 1000. you'll make one more equation, the same equation. In the next equation, you'll keep omega final 0, omega initial omega naught minus 2 alpha theta. Now from both the equations, replace alpha, you'll get the value of theta. So theta is what? Theta is the angle rotated, or in terms of rotation, number of rotations till the body rotates, stops completely from the beginning. And you have been asked how many more rotations will be completed after omega naught by 2. So जो पहले वाले rotations हैं, total rotations में से पहले वाले rotations 1000, you'll subtract and you'll get the result. I hope through this example you must have got how these kind of questions are to be tackled. The main thing is what? They are exactly like what you have done in case of translation mechanics. Here the questions are relatively easy. Here the questions are not that tough as you got in case of 1D motion. Here the parameters are simple. Generally it's the simple use of all those equations. Yes, questions will be related to the calculus also. Like there you used what? A equals to dv by dt. V equals to v equals to what? Dx by dt. Here you'll have what? Alpha equals to d omega by dt. Or alpha is also equal to omega d omega by d theta. Is that clear? And omega equals to what? D theta by dt. You have all these kind of equations. You know, like in the translation mechanics, you generally use the calculus when it is desired. Like suppose they give you the value of x as a function of t. They ask you to calculate the velocity. You do what? Dx by dt. They give you the velocity as a function of t. They ask you to calculate the acceleration. What do you do? dv by dt. Similarly here, if they give you the theta as a function of t, they ask you the omega d theta by dt. They give you the theta as a function of t, they ask you to calculate the alpha. So first of all find omega by d theta by dt, then d omega by dt will be the alpha. So these are simple questions in which differential calculus is to be used. Otherwise, in what cases the calculus was to be compulsorily to be used? They were the cases when a was not constant. Similarly here, if alpha is not constant, alpha is a function of time t, alpha is a function of omega, or alpha is a function of theta, then be using these kind of equations, then separating the variables, then integrating for the limits given, and you'll get the results. But see, in the translation mechanics, there was 2D motion also, and 2D motion was a big part, projectile and all. Here, you don't have any questions like 2D. The reason being, if the body is rotating, usually the body is rotating about a fixed axis. So the direction of axis is not changing, and because the direction of axis is not changing, omega, alpha, theta, they will all be directed along what? Axis. So here you can say in the rotation dynamics, related to the rotation, all the questions that you'll have, they are like 1D questions. Because see, in case of translational mechanics, you had 2D questions. In what way? If initial velocity and initial acceleration, they were directed along two different directions. Or in the same questions, there were two velocities along two different directions. Like one, the velocity of flow of river, one, the velocity of swimmer, they were in the different directions. You also tackled that question as a case of 2D motion. Here, because these parameters will be directed along the axis only. Because see, these parameters are directed along the axis only. So what will happen that there will be only 1D kind of questions here. So this is related to the this about the kinematics of rotation. Then see, the first kind of questions, when you know all these parameters, are what? In which first the torque is 0 as well as the force is also 0. Means torque will be acting, but the net torque will be 0. Torque is acting, it's not that torques are not acting. Net torque is 0, net force F is also 0. So it's like, see this. आप देखेंगे, जैसे there is a rod of mass m in length है. It's one example. The questions will be like that, but the figures might be variable. The nature of the question will be what? Same. Now from one end, one string is attached and other string is attached at a distance L by 4 from one end. These are suspended like this, see. Now you have to calculate what will be tensions in the string T1 and T2. Look at this. In all such questions, you'll make the FBD like T1 and T2 are upwards, weight will be acting downwards. Because see, the observation is what? Body is neither rotating, body is not translating. It's not rotating and translating. It means if there are forces in the upward direction, the upward forces will be equal to downward forces. Similarly, if there are forces along left, they'll be equal to what? Forces along right. Because net force is 0, it's not that forces are not acting. Forces will be acting, but the net force will be 0, so you'll have to make the equation for the equilibrium of forces. Similarly, because the body is not rotating, but the torques are acting, I take the torque of forces about the center of mass. So torque of T1 about the center of mass is what? T1 into L by 2, and that is what? It's of clockwise sense. And torque of T2 about the center of mass is of anti-clockwise sense. So clockwise sense torque will be equal to what? Anti-clockwise sense of torque, and torque of weight mg will be what? 0. One more important point, that I took the torque about this point. It's not necessary that you'll be guided absolutely as I'm guiding you in the examination conditions also. Whatever your brain wants to calculate the torque about that point. The final concept is what? If the body is not rotating, torque about any point will be 0. If the body is not rotating, it's in rotational equilibrium, the torque about any point will be 0. So about whatever point you are calculating the torque, you have to see what? The clockwise torque will be equal to what? Anti-clockwise torque. You have to take that. Clockwise torque will always be equal to what? It will always be equal to anti-clockwise torque. So these are the questions in which torque is 0, force is 0. That is, forces are acting, torques are acting, but the clockwise torques are equal to the anti-clockwise torque. In the left hand side, forces are equal to the right hand side forces, means forces can also be balanced. Next kind of questions are what? Second kind of questions in which force is 0 but the torque is not 0. Force is 0 but the torque is not 0. So these kind of questions eventually get converted into what? Kinematics kind of question. The only thing is that, like suppose they have given you that there is a ball and there is a rough surface, horizontal surface. There is a cylinder of mass m and radius r. It is given an angular velocity omega naught and is kept at the corner. Coefficient of friction between the wall and the cylinder is mu, between the ground and the cylinder is mu. After how many rotations will it stop? After how many rotations will it stop? Initially it was rotating, then the rotation is being stopped. That means negative alpha must be there, then only it will undergo retardation, and eventually after some time it will stop. Is that clear? Could you understand this? Omega naught is there, final omega is 0, it means alpha negative, that is retardation, must be there, because the body is not translating. So net force will be what? 0. We mark the forces like mg, reaction n1 from this surface, reaction n2 from here. Because see, rotation is like this, so the force of friction at this surface will be mu n1. Force of friction at this point will be upwards because rotation is like this, that will be what? Mu n2. So the equations will be what? n1 plus mu n2 will be equal to weight mg, and n2 will be equal to what? Mu n1. Left hand side forces will be equal to right hand side forces. The upward forces will be equal to what? Weight mg. Is that clear? n1 and n2, these are two forces which you can calculate by the equations. When you get the n1 and n2, then the final target was what? It was to calculate the torque. So we calculate the torque about the axis of rotation. You see, torque of n1, torque of n2, torque of mg will be 0 because they are passing through the center. So torque of mu n2 will be mu n2 into r, and torque of mu n1 will be mu n1 into r, and both the torques are of anti-clockwise sense. Rotation is in the anti-clockwise sense, and both the torques are what? Clockwise sense. Both the torques, they are of what? They are of clockwise sense. So these torques will be equal to what? I alpha. I will be equal to what? I will be equal to half mr square into what? Alpha. Keep the value of n1 and n2 from here. You'll keep the value of n1 and n2 here. You'll get the value of what? Alpha. इससे आपकी alpha की value जो होगी आ जाएगी. When you get the value of alpha, you'll do what? Omega final square equals to omega initial square plus 2 alpha theta. Omega final is 0. Omega initial is what? Omega naught square minus 2 alpha into theta. You get the value of alpha from here. That value of alpha you'll keep here. You'll get the value of theta. So this will be the angle rotated till then the body stops rotating. A number of rotations will be what? Theta upon 2 pi. So as I told you, in these kind of questions, what is there? Make FBD, question might be in the variable form, but don't worry about that. And there's the best thing about the physics, that there are some fundamental laws which need to be applied. And you have to follow those instructions. If you follow and categorize the questions according to that, there cannot be a question, as I'm telling you today, that the question that will be getting this year also, that question can be tackled through all these concepts which I'm discussing you. So make the FBD, because the body is not translating. Net force will be 0. So through that you can get two equations, one for one direction, other for the other direction. Then torque is not 0. So take any point, calculate torque about that point, net torque, then torque tau equals what? I alpha. That alpha can be used for the any kind of kinematic calculations. Kinematic calculations means like this kind of a calculation. Achha, one more point I just forgot to tell you the calculation of angular momentum in one case. Look at that, because that has, I have observed that calculation has been asked in some of the years. That calculation has been asked. Look at this. Particle is of mass m. It's moving with the velocity v. Velocity v is given in the form of I cap, j cap, k cap. You have to calculate the angular momentum about the point O1, and O is the axis of Cartesian system's origin of coordinates. This is the origin of coordinates. The position vector of the particle is vector r1. It is vector r2, and position vector of point O1 about which you want to calculate the angular momentum. The point about which you want to calculate angular momentum O1 is position vector r1. And position vector where the particle is what? r2. Velocity of the body is what? v. In that case, the angular momentum L will be equal to r cross p. And r is what? r2 minus r1. So all this calculation will be in the form of what? I cap, j cap, k cap, cross p. Cross p will be what? mv. So through that you can get the value of angular momentum L in the vector form. Is that clear? Now see the third kind of questions, in which will be those in which neither force is 0 nor torque is 0. The third kind of questions will be in which force is not 0 and even torque is not 0. Neither the force is 0 nor torque is 0. There are most of the questions fall into this category. Like you must have done, there is a cylinder rolling on a rough incline, angle of inclination is theta. Cylinder is rolling on a rough incline, what will be its acceleration? So you know that there are two things. One, question could be related to what? Pure rolling. Pure rolling means rolling only, rolling without slipping. When it is related to the rolling without slipping and you want to calculate the acceleration A, what you have to do? There are two methods. This for the rolling kind of questions. You want to calculate any parameter. There are two kind of methods by which you can do that. One is the method of force and torque. Make it FBD. Take force of friction F. Because see, coefficient of friction is not given. Only this is given that body is in pure rolling. So for the rolling, maybe some friction is needed, and that friction can be provided by that surface also. So make one equation for what? Force F equals mass m into A. Net force, as you have been making the FBD in the Newton's laws, similarly you will make the FBD here also. F equals what? Mass m into A. And the next question will be what? Take a suitable point, take torque about that point, net torque about that point, torque tau will be what? I alpha. So that will be I alpha, alpha will be what? A by R. This is the method of force and torque. This is one method by which you can get what? A, or you can get what? Alpha. Is that clear? Now see, the other is what? Other is the method of energy conservation. You see, if the body is in pure rolling, that is, there is no slipping. There will be no loss of energy against the friction. Because there is no loss of energy against the friction, then the one equation will be like body falls from this point to this point. Vertical height that the body has fallen is say h, then mgh will be equal to half mv square plus half I omega square. And one equation will be the third equation of motion, v square equals u square plus 2as. So u is 0 at this point. The value of up to this point, what will be the value of s? Keep the value of s. Then you get one equation a here. You get one equation v square equals to v square you get in terms of a here. And this, because this is a pure rolling, omega square will be equal to v square by r square. You keep the value of V square here in terms of what A, get the value of what A. So if there is no slipping, then energy will not be lost even if friction is present there. So by using that condition, what will you do? Make one equation for the law of conservation of energy, one equation for the V square equals to U square plus 2As, and you will be able to solve the question for the A. Now see, after this say, like this was the motion of a body on an incline. I give you the example when the body is lying on a horizontal floor also, like it is this say. Suppose this is a solid sphere. It's a solid sphere. And the solid sphere is lying what? This solid sphere is of mass m, radius is r. There could be two kind of questions here. One kind of question could be what? One kind of a question could be that you are applying some force on the body at any place. This is smooth surface. Initially we take that this is smooth surface. And examiner gives you that you apply force somewhere F at this point. Somewhere F at this point. They can ask you at what location the force must be applied so that the motion of the body is pure rolling from the beginning. You see that there is no friction. There is no slipping. The motion is pure rolling. What you have to do, this is also all based upon the force and torque method. What we do, because see, you are applying the force F, so acceleration of the center of mass will be what? F by m, as there is no friction. The surface what? Is smooth. Now see, the torque of this force about this axis will be what? F into x. There is a torque tau. And torque tau will be equal to what? There is no other force. The force is there, mg is there, n is there, but because they are passing through the center, so net torque about the center will be what? F into x only. This torque tau will be equal to what? I alpha. I is 2 by 5 mr square into what? Alpha. Now because see the motion has to be of pure rolling, then alpha should be equal to what? A center of mass divided by what? R. Alpha should be equal to what? A center of mass divided by R. So in that case, you will keep this value here, get the value of x. So this kind of a question becomes when there is no friction, body is lying on a smooth floor, is still by applying a force at a suitable point, they can ask you to calculate what should be the distance of that point of application of the force so that the motion is of pure rolling from the beginning. Is that clear? Motion is of pure rolling from the beginning. Now see, in such cases, the surface could be rough also. And what could be the question in that case? Suppose they say, there is a solid sphere, they apply a force at the topmost point, the force is F, the surface is rough, coefficient of friction is what? It's mu. Coefficient of friction is what? It's mu. Now see, the variety of question could be like in what way? Listen this carefully. They apply the force F at this point, they can ask you what is the maximum value of F for which motion is pure rolling. What is the maximum value of F for which motion is rolling without slipping? In that case, what you have to do? See, take the direction of force of friction, what? Forward. You do not know what will be the direction of force of friction, really forward or backward. We take the direction of force of friction, say F, forward. And we take that, its value is what? F. Now see, the one equation becomes F plus F equals what? Mass m into A. The other equation becomes F into R minus F into R equals what? I alpha. Because the motion has to be of pure rolling, you keep alpha equals what? A by R. Is that clear? Now in this question, what are the two unknowns? Extension A is one unknown because you have to calculate the F max. Now force of friction you will take what? Force of friction you will take mu mg. And don't worry about such questions like if they give you the value of force F, I'll tell you later. Just look at this. In this case, maximum value of force of friction will be what? Mu mg. You keep that value mu mg. Now there are two unknowns A and F. Because you have taken the maximum value of force of friction mu mg, so the value of capital F that will be the value of what? F max. This is one kind of question. Is that clear? And the force of friction is what? It's mu mg. Now see, there could be other kind of question. What? They tell you that surface is rough. We apply a force F at the topmost point. and we find that the motion is rolling, pure rolling, there is no slipping. Force F is applied at the topmost point, and the motion is what? It's pure rolling, there is no slipping. Calculate the value of force of friction F. Calculate the value of force of friction, even the direction is not known. You took that force of friction is what? F. F plus F equals to mass m into A, and F into R minus small f into R, because one torque is clockwise about the center, other torque is anti-clockwise about the center. So net torque tau equals what? I alpha. Alpha is what? A by R, because it is a pure rolling. Now here capital F is known and mass m is known. Because the body's shape is known, solid sphere, you'll keep that what? 2 by 5 mr square. So what becomes unknown? A and small f become unknown. You'll get the value of small f. You get what? You get the value of small f, that is the force of friction. If in some case that you get that the value of f is coming to be negative, then the direction of force of friction will be opposite to what you have taken. And if the value of force of friction is positive, the direction of force of friction will be same as you have taken, the value of A will also come. Now see, for the pure rolling, this maximum value of force of F, force of friction, cannot exceed what? Mu into N, that is here mu into mg. Means what? If in some case you have to determine that for this given force, the motion will be pure rolling or it will not be pure rolling when the force has been applied at this point. You have made the equation, you kept the value of capital F, you got the value of small f, they giving you the coefficient of friction, then you calculated the value of mu mg. If you found that the value of force of friction that is coming through these equations is greater than mu mg, in that case pure rolling will not take place, that is rolling with slipping will take place. Is that clear? Now see, in all such questions, when the question is related to the rolling with slipping, means it's not a question of pure rolling, even if that is one of the fundamental question like theta, cylinder, mass m, radius r, they give you that friction is not enough to allow pure rolling. Now how to study its mechanics? Simply mg sin theta, and this what? Mg cos theta. This force of friction F, you do not know what is the value of F, and even if the coefficient of friction is given to you and they say that the friction is not enough to allow pure rolling, then the force of friction F will be equal to what? Maximum, that is what? Mean to N, that is mean to mg cos theta. Mean to N into mean to N. So that is what? Mean to N, that is what? Mean to mg into cos theta. This will be the value of force of friction if they say that friction is not enough to allow pure rolling. Now the equations will be like what? Mg sin theta minus F will be equal to mass m into A, and F into R equals to I into alpha. Now alpha will not be equal to A by R. The angular parameters will be calculated separately and the linear parameters will be calculated separately. Suppose they ask you what will be its kinetic energy when it reaches the bottom. This height h is known to you. This h. So this becomes what? H over sin theta. So through this equation you got the value of A. You'll apply V square equals to U square plus 2AS. So S becomes what? H over sin theta. Keep the value of A, you'll get the V. Through the V you can get the kinetic energy of translation. N to get the omega. What will you do? Calculate the time till then. V equals to U plus AT. So because you know the value of V, you know the value of U0, you know the value of A, get the time T. Now after that time, what will be its omega? Apply the equation omega final equals to omega initial plus alpha t. Omega initial is 0. The value of alpha you get from here alpha, get the value, you have got the value of t, keep that value of t, you get the omega. So you will get the rotational kinetic energy half I omega square also, and you got the value of velocity v, the kinetic energy of translation half mv square, that will be the total kinetic energy. In the sum of the two kind of energies you will find will be less than the mgh, because slipping was taking place, so there will be some loss of energy against the friction also. So these are the questions related to what? Force and torque. Means what? Force and torque may, torque could be due to the string force, the force could be the string force tension T also, but the methods will be like this only. There will be only these equations, one equation for the Newton's law, the other equation for the tau equals to I alpha, and if there is no loss of energy, then the loss of potential energy equals to gain of translational plus rotational kinetic energy. In the other equation, v square equals to u square plus 2as. Is that clear? Now see, we have the questions based upon the law of conservation of angular momentum. So questions based upon the law of conservation of angular momentum. They are like what? See, they'll be in this form. The first kind of question, the simplest kind of questions are what? You have a body rotating about a fixed axis, suppose it is rotating about an axis, vertical axis. It's rotating with an angle velocity omega naught, rotating with an angle velocity omega naught. Now, what will they tell to you? Some mass is dropped on it. Some mass is dropped on it. Its mass was capital M. Some mass small m is dropped on it at a certain distance x from the axis of rotation. Or some mass is gently kept on it at a certain distance x from the axis of rotation. Initially the disk was rotating with angular velocity omega naught. What will be the final omega? What will be the change in kinetic energy? What will be the loss of energy? What will be the gain of energy, etc.? These could be the various kind of questions. What you have to do? Because there is no external torque, I1 omega 1 equals to I2 omega 2. I1 is what? Half mr square of the disk, half mr square of the disk into omega naught. Final I is what? Half mr square of the disk plus mx square. Plus mx square, this is of what? This is of the block which will be like a particle into what? Omega. You get the omega? So because you got the omega initial, you have the omega final, you got the omega final, you have the omega initial also. So you can find the change of energy or the loss of energy or the gain of energy, whatever happens in all such cases. So here see, the question was what? The axis of rotation of the body was fixed and you were keeping some mass gently here. Then what was the final omega? Because torque was 0, so angular momentum will be considered I1 omega 1 will be equal to what? I2 omega 2. Now see, the similar question, similar kind of questions could be what? The questions could be like this also. The disk, I'm taking in my example the disk, the body could be anything. It could be a sphere, it could be ring, it could be anything else. You take the I for that body. Now the disk is of mass m radius r, it's rotating with the angular velocity omega naught. Initially, when the disk angular velocity is omega naught, there is an insect of mass small m at a distance x from the center, x from the axis. Now the insect goes to the circumference by himself, he goes to the circumference, moves to the circumference. What will be the final omega? What will be the gain of kinetic energy? What will be the loss of kinetic energy, etc.? Those kind of questions. Once again, because there is no external torque, I1 omega 1 will be equal to what? I2 omega 2. So in this case, initial I1 is what? Half mr square of the disk plus mx square of the insect into omega naught. That will be equal to half mr square of the disk plus mr square of the insect finally into what? Omega. Through this equation, you will get the value of what? Omega, and by calculating omega, you can calculate the final kinetic energy. So you can get the loss of kinetic energy or the gain of kinetic energy. And like you know that in case of translational motion, the relation between momentum and the kinetic energy is what? Relation between momentum and the kinetic energy is P kinetic energy K equals to P square by 2m. So here also you should establish a relation between the rotational kinetic energy and the angular momentum. Relation between the rotational kinetic energy and the angular momentum is what? You see that L equals to I omega. So L square equals to I square omega square. We separate one I, multiply by half, multiply by 2. Is that clear? So this is what? It is K. So L square equals to 2I into K. It becomes what? So that is what? It becomes L square equals to 2I into K. Means these kind of questions will be useful if they tell you that the angular momentum has been doubled. What will be the percentage change in the kinetic energy? So you can get that. If this quantity is doubled, what will become the final kinetic energy? You can calculate that. Then through the change of kinetic energy, you can calculate that how much is the percentage change of the kinetic energy. So see, in this case of law of conservation of angular momentum, what was the basic thing? That the mass of the system was constant, there was no external torque, mass was constant, only the redistribution of mass was taking place. Means some mass is going away from the axis or some mass is getting closer to the axis. So in that case, the change of omega and the change of kinetic energy of rotation can be calculated by applying the law of conservation of what? Angular momentum. Now see, there could be a question like this also, like there is a rod of mass capital M, n of length L, mass M and length L, and some block of mass small m strikes at one end of the rod and sticks to it. What will be the maximum angle of rotation made by the rod in the from the vertical position in equilibrium? Not in equilibrium. Maximum angle rotated by the rod in the subsequent motion. Now see, initially because see axis of rotation is fixed. If you take that, the block and the rod, they make one system, there is no external torque. So what will you do? You'll apply the law of conservation of angular momentum about this point, mv naught into L. This is the initial angular momentum of the block. And because there was no rotation in the rod initially, so there is no angular momentum of rotation of the rod. So mv naught L, that will be equal to immediately after the block gets fixed with the rod, the total body means rod plus block will start rotating about this axis. So that will be 1 by 3 ml square moment of inertia of the rod about one axis, about an axis passing through one end, plus moment of inertia of the block. How this becomes I into omega. You'll get the value of omega. So through that you can get what? You can calculate the initial kinetic energy immediately after the block gets stuck to the rod. And that kinetic energy of the combined system, half I omega square, will be converted into what? Gain of potential energy of the block, gain of potential energy of the rod, as the center of mass of the rod is rising and the position of block is also rising. So the gain of total potential energy at this extreme position will be equal to initial kinetic energy of the rod plus block system immediately after the collision has occurred. So through that you can get what? You can get the value of omega. So you see, you applied the law of conservation of angular momentum. In this case, when the one mass has come from outside, here one mass was coming from outside and that mass was also bringing some angular momentum to the system. So that means what? In such cases also, if you take that block and the rigid body, that block and the rigid body, they make one combined system. The block and the rod, they make one combined system. Then the initial angular momentum, sum of the initial angular momentum of the two will be equal to sum of the angular momentum of the two immediately after the collision has occurred. Through that you can get the value of what? Combined omega, and then you can calculate the, you can go for the calculations related to the kinetic energy. Then see, now see one more thing, like suppose you have been given, there is a rod lying on a horizontal plane. This rod is lying on a horizontal plane like this, see. Mass is m, length is L, it's not fixed somewhere, and there is no friction between the rod and the ground. Now some impulse is given to it at some point. Suppose some impulse m, this is all in the horizontal plane, impulse is p is given at this point. Now how the motion will take place? The center of mass of the rod will start moving with the velocity p by m. M is the mass of the rod, and the rod will rotate about the n-axis that passes through the center of mass. That will be called what? P into L by 2 is the angular momentum of the p about the point which is lying on the ground, and the point is just below the rod. The point is where? Point is just below the center of the rod. So P into L by 2 is angular momentum about that point, and that will be called what? That will be I omega 1 by 12 ml square for the rod into omega. So I mean to say what? When a rigid body is not fixed on axis, there is no friction also. At whatever point you give some impulse to it, the center of mass will always have a velocity what? Impulse imparted upon mass m. And the rigid body will always start rotating about the axis that passes through the center of mass. And what will be its angular velocity? Omega, the impulse that you have imparted. Calculate the angular momentum of that impulse about a point which is lying on the ground just below the center of mass of the rod. So that angular momentum will be called what? I omega. Body will start rotating about the center of mass So in that case, you'll calculate the value of what? You will calculate what? You will calculate the value of I about the center of mass, I into omega, that will be equal to initial angular momentum. In such cases, there could be a little tougher cases. What? Suppose the block of mass m was striking to the rod. Rod means rigid body. At one end or at not one end, somewhere else. Now what will happen in such cases? And after that collision, the block sticks to the rod. Block sticks to the rigid body. Once again, see what will happen. That the combined center of mass of the system will begin to move with a velocity v center of mass equals what? Momentum of the block, because rod was not having any initial momentum. Momentum of the block upon total mass capital M plus m, that will be the velocity of the center of mass. And the body, the rigid body will start rotating about that point on the ground which is lying just below the center of mass. It will start rotating about that point which is lying just below the combined center of mass. Suppose the combined center of mass when the block sticks at this point is at this point. You can calculate that position. The position of the combined center of mass from this point will be what? Capital M into L by 2 plus small m into 0 divided by capital M plus small m. That is the distance of the center of mass from this point. Now what you have to do? Apply law of conservation of angular momentum about the point on the ground which is lying just below this point. What is the position of the center of mass? So that will be what? mv into x. X you have already calculated. mv into what? X. This is the initial angular momentum. That will be equal to what? I into omega. Now find the combined I of the system about this point. Means what? You know the momentum force of the rod about the center of mass by the theorem of parallel axis. This distance will be what? L minus x, L by 2 minus x. Get I of the rod about this point, get I of the block about this point, mx square, that combined I into omega, you'll get the value of what? Omega also. So through this you can get the value of what? Omega also. Now see, similarly, there are some important questions which are like what? Suppose you have a sphere of mass m radius r. This might be lying on a rough floor or on a smooth floor. Like I have given you the example just now, in which this could be smooth or this could be rough and force was imparted. Now they won't impart the force, they'll impart what? Momentum. They'll impart what? Momentum P. If this was smooth and they ask you that at what distance above the center the momentum must be imparted so that its motion starts pure rolling from the beginning. It will be like this, see? Because friction is not there, what you do? Take angular momentum out this point, P into X is equal to what? I omega. P into X is equal to what? I into omega. I about this point, get the value of omega. Also because P momentum has imparted, so velocity of center of mass will be what? P by m. You got the value of omega from the previous equation, then velocity of center of mass will be equal to what? Omega into r. This is the condition of pure rolling, and through that you get the value of what? X. Now suppose this rough, coefficient of friction is, or they say it's rough, and impulse P is imparted to it at a distance x above the center. With what? Angular velocity. This will start rotating from the beginning. It is given that the motion is pure rolling, friction is enough. The equations will be what? Equations will be like the seen this way. Even if this is rough, you need not to consider the force of friction. It will be like P into X equals what? I omega. Put the value of I, get the omega. And P equals what? Mass m into V center of mass. So m into V center of mass, and relation between V center of mass and omega from these two equations will fulfill this condition. This will be the equation in that case, even if it had been rough also. Now one more question becomes what? Suppose the coefficient of friction is mu, and they are imparting the impulse at such a point that in the beginning the motion was not pure rolling. They are imparting the impulse at such a point that the motion in the beginning is what? It's not of pure rolling. Motion is starting with pure rolling ka nahi hai. Now, after what time pure rolling will start? What you have to do? P into X is equal to I omega, get the initial value of omega. And P into P equals mass m into V center of mass, get the value of V center of mass. So what will happen? either V center of mass will be greater than omega into r, or V center of mass will be what? Less than omega into r. Will be what? Less than omega into r. If V center of mass is greater than omega into r, then force of friction will be acting in the backward direction, and that will be what? Mu mg. That will be what? Mu mg. So through the mu mg, the retardation force will be what? Mu mg upon mass m will be the retardation, that will be mu g. What you do? Let the motion starts of pure rolling after time t. Then after time t, the velocity v will become what? U plus at. U is v that you had calculated, v center of mass, minus mu g into t. That becomes the velocity after time t. Similarly, the calculated torque of the force of friction, mu mg into r equals y alpha. So through that you will get the value of alpha. Because omega was less than the v, so omega will gain. So omega final equals what? Omega initial plus alpha into t. You had the initial value of omega plus alpha, keep the value of alpha into time t. The final omega that you are getting after time t and the final velocity that you are getting after time t, keep that v equals omega into r. You will get the value of what? Unknown. So these are kind of questions. You see, in the same category, there are two very popular questions. What they are? They'll give you somebody, maybe a sphere, disc, cylinder, whatever it be, and they say what? The surface is rough, coefficient of friction is mu. In initial velocity imparted, translational velocity imparted is what? V naught. It's not given any rotation. After what time the pure rotation will start? What will be its velocity there? What will be the loss of kinetic energy till then? It's the same thing. What you have to do? In this case, force of friction mu mg will be in the backward direction. So retardation in the backward direction will be what? Mu g. So let velocity after time t becomes what? V. V equals to v naught minus mu gt. And the torque of force of friction mu mg into r will be equal to what? I alpha. Get the value of alpha. Then apply the equation v omega final equals to omega initial plus alpha t. Omega initial is what? 0 plus alpha, keep the value of alpha into t. The final v and omega that you are getting, relate them v equals to omega r, because finally the pure rolling is starting, so v equals what? Omega r. You'll get the value of unknown, and through that you can get the velocity v at that point, you can get the omega at that point, you can get the total kinetic energy at that point. Initial kinetic energy you knew half mv naught square, so through this you can also account for how much energy has been lost. And it's opposite, it's reversed question. That is what? Initial angular velocity is omega naught, it's kept on a rough floor, coefficient of friction is mu, no translational velocity has been given. After what time its pure rolling start, what will be its velocity at that moment, what will be its omega at that moment, or account for the loss of kinetic energy till then. Once again now see, because omega naught, there is no velocity v, so force of friction will be in the forward direction, force of friction will be mu mg equals mass m into a. You got the expression a what? Mu g. After time t, say velocity becomes v and omega becomes omega. V equals u plus at. U is 0, a that you calculated mu g into t. Then because you know the force of friction torque, mu mg into radius r equals what? Torque tau equals I alpha, get the value of alpha. Omega equals to omega naught minus alpha t, because see the rotation is clockwise and the torque is anti-clockwise, minus alpha into t, keep the value of alpha into t. The final omega and final v that you are getting, relate them v equals what? Omega into r. You'll get the value of t, then through that you'll get the value of v omega, and you can calculate each and everything. These two questions, the last questions, can be done by applying law of conservation of angular momentum also about this point, because see all the forces are passing through this point mg, and force of friction either in the forward direction or in the backward direction, it passes through this point, so torque about this point is what? 0. So what you can do, when it has got only omega naught, calculate angular momentum about this point. When it has got v and omega both, calculate angular momentum, because in that case v and omega will be related when the motion pure rolling has been started. So calculate the value of angular momentum at that point also in terms of v or omega, you'll get the value of unknown, and through that also you can solve it. So these were the different varieties that may come in the JEE main or NEET paper. I kept the toughness not much, it's exactly as per needed for the JEE main and NEET exam, and I hope I have covered. I feel that I have covered all kind of variations that have been asked in the previous year questions, previous year JEE main or the NEET exam. So hopefully even if you can grasp all this and you can apply all this thing in the questions, still your JEE main or NEET question will definitely be solved. So all the best. Now next time the sprint that I'll do will be in the waves. Okay, all right.